Let's look at OpenStax College Physics, Chapter 4, Problem 27. A freight train consists of two 8 times 10 to the 4th kilogram engines and 45 cars with average masses of 5.5 times 10 to the 4th kilograms. What force must each engine exert backward on the track to accelerate the train at a rate of 5 times 10 to the negative 2 meters per second squared if the force of friction is 7.5 times 10 to the 5th newtons, assuming the engines exert identical forces? This is not a large frictional force for such a massive system. Rolling friction for trains is small, and consequently trains are very energy-efficient transportation systems. B. What is the force in the coupling between the 37th and 38th car? This is the force each exerts on the other. Assuming all cars have the same mass and the friction is distributed evenly among all of the cars and engines. All right, so here we have our diagram, and then we'll have to write down our knowns and unknowns. So what we know is that the train consists of two engines. I'm going to call them on the diagram. Let's see, make them mass 1, mass 2. And we know that both of those masses are equal. So M1 equals M2 equals, I'm just going to call it capital M, uppercase M, and that is 8 times 10 to the 4th kilograms. And then there are 45 little cars, so I'm going to call them M1, M2, and then there's dot, dot, dot here. Let's call this M37, M38, and so on, and this is M45. And all of those masses are the same, so lowercase m1 equals lowercase m2 equals dot, dot, dot equals, I'm just going to call it lowercase m, and that is 5.5 times 10 to the 4th kilograms. Then we know that the train attains an acceleration of 5 times 10 to the negative 2 meters per second squared. And there is a friction force, I'll call it lowercase f, of 7.5 times 10 to the 5th newtons, retarding the motion of the trains. So in the first part, we want to know the force that the engines exert to move the train. So I'm going to call it force engine 1, which is equal to force engine 2. So we're looking for that. And in part B, we're looking for the force between the 37th and 38th car. And we are given a little clue here. They're saying that this is the force exerted, each exerts on the other. That is a normal force, the normal force between them. But since we don't have them, since there is another little clue that we have here, and that's there's a coupling between them, then there is a tension force in that coupling. So you can either look at this as normal forces or as tension forces, and they are internal forces. So one goes to the right, one goes to the left, and they have the same magnitude. So then I can just solve for one and not the other, but I know that they're equal and opposite by Newton's third law. So I'm just going to call this tension between the 37th and 38th coupling, or sorry, train car. So that's what I'm looking for. All right. So I know that the engines will exert enough force to move themselves and all of the 45 cars and overcome the friction force. And as a result of that, they move at an acceleration of 5 times 10 to the negative 2 meters per second squared. So I can use Newton's second law and say that sum of the forces on the entire train will be the mass of the entire train times the acceleration. So the forces are going to be force of engine 1 plus force of engine 2, and both of those forces will act to the left. So this is force engine 1 this is force engine 2, and the friction force is going to retard the train's motion, so that's going to be in the negative direction. So I'll have it as minus friction force. So that is equal to the mass of the train, so that is 2 masses of the locomotive or engines plus 45 masses of the cars times the acceleration. So since I know that the force of engine 1 equals the force of engine 2, I can just say that we have here 2 times force of the engine, and then when I solve for just one of them, force engine 1, which equals force engine 2, that's going to be the friction force plus 2 uppercase m plus 45 lowercase m times the acceleration divided by 2. And when you plug in the numbers, I'm not going to do that because I won't have enough space, you end up with 4.41 times 10 to the 5th newtons. So each locomotive exerts this force to make the train move at an acceleration of 5 times 10 to the negative 2 meters per second squared. Now in the second part, we're looking for the force that is exerted between cars 37 and 38. So if I just look at cars 38 through 45, I know that the only reason they are moving to the left is because this tension between the two sections of the train pulls them. So there is this tension force that pulls all of these cars with the acceleration that we were given of 5 times 10 to the negative 2 meters per second squared. And that amount of tension also has to overcome the friction that is exerted on cars 38 through 45. So when I write some of the forces on 38 through 49, that's going to be the mass 38 through 49 times 45, sorry, not 49, times the acceleration. So let me get rid of the 9 and make that a 5. All right, so some of the forces then is going to be this tension that pulls those cars along minus the friction. And we're told that the same amount of friction acts on all of the cars. So there are 45 cars plus 2 locomotives, that's 47. So 38 through 45 is 8 cars. That means that we have 8 divided by 47 times the friction force. So only this much friction acts on the last few cars. And that's going to be equal to 8 times the mass of one car times the acceleration, which then means that the tension will be 8 times mass of one car times acceleration plus 8 over 47 of the friction force. So that is 8 times mass of one car, which is 5.5 times 10 to the 4th kilograms, times the acceleration, which is 5 times 10 to the negative 2 meters per second squared, plus 8 over 47. And the friction force is 7.5 times 10 to the 5th newtons. So that means that the tension, once we plug in the numbers, is going to be 1.50 times 10 to the 5th newtons. So the tension between cars 37 and 38 in here is going to be very large, 1.5 times 10 to the 5th newtons. Now, we could have done this in a different way. We could have said, okay, we know that the reason that these trains are moving, the 2 locomotives and those cars are moving, is because there are the 2 engines pulling it along. There is the friction of 47 minus 8 cars, and there is also going to be this other force that those 8 cars pull onto the 37th car. They retard that 37th car. So we could have looked at it from the other point of view, from the first set of cars rather than looking at the last set of cars. We would have gotten the same answer. I just chose the shortest, easiest solution for this problem.